Going to do a review of the standard normal distributions. Remember, that's where the mean is 0 and the standard deviation is 1. How to use the Numworks calculator on those. And then we're going to look at just regular, not standard, normal distributions where the mean is something other than 0 and potentially the standard deviation is not equal to 1 in both of those. And you can click through this presentation as well, and this is a working Numworks calculator on the right. So let's start off with how do we use the Numworks calculator. Well, you'll notice that there's a menu system with Numworks, and so you can arrow around in the menu system. We want to arrow down. What we want to do is work with distributions. So that's this here. As soon as we hit OK, we should get to the listing of all the different distributions that are available. The previous chapter we looked at binomial. In this section we are looking at the normal curve. We could actually do all of these various ones as well, so you can play around with those, but we are going to be looking at the normal curve as mentioned here. So we will go ahead and click the OK key. And as soon as we do that, we are brought to the place where we can enter the mean, as mentioned here, with the Greek letter mu, and the standard deviation with the Greek letter sigma, little sigma and little mu. For the standard normal, it's always the mean is 0 and the standard deviation is 1. So that's where we're going to start, and we just need to. Now notice you might try to click, but it's not a touch screen. You have to use the buttons to navigate. We'll go to the next one. So as you come to the next one, what we want you to see is it doesn't pop up right away, but there are 3 different sort of subtools in here. So if you arrow to the right and hit the down arrow, you will see you have your 3 different icons. The first icon is for less than. You've got here less than or equal to. And because a normal distribution is continuous, less than or equal to is the same as less than, because at a particular value, the area is 0. Let's just put it that way, we'll say. But whether it's less than or equal to, we will use this tool. As you come down to the next one, there's the other 2 tools, and we'll explore those a little bit more in the next screen. So there's the 3 different tools. Less than, which is to the left. You may see that wording. The middle one is the between, so you'll be giving 2 x values. We'll see how that works. And the last tool is for when we want the area greater than. Now, in doing it this way, we save ourselves a lot of calculations that we would need to use if we were using a old school table or even some of the older calculators. So let's look at a couple examples. So the first one which comes up is the less than. So x less than 0. 0 is the mean, so the amount less than 0 is 50%. Half of the curve is below the mean. That's all that's really telling us, and we get that by putting in here. And again, what we'll see is we can put any value in here, say negative 0.5, so that's a z-score of negative 0.5, and it will adjust and it will tell us what percent is in there. Okay, so this is an example of x less than 0. Notice it's less than or equal, but that's the same values, so we get 0.5 or 50%. The next one is the between tool. So to do that, we arrow over to the side, we arrow down, and we select the icon that has the shading between. Notice as soon as we do that, there are 2 values. There's one to put for the left side of x and one to the right side. So we're going to get the area between 2 values. And again, this is an example of being between the mean, which is 0, and 1 standard deviation is 34.13%, or 0.3413 to 4 decimal places. And again, as we go through this, we can enter any values that we need to from our problem to get the area between two x values. Whatever we're given, we can put in here, and notice it's going to give us the area between two z-scores. And the graph will show us the area, and we're given the area here. And finally is our tool that we come over here, icon to the right, and we're going to use the last one, which is greater than, the shadings to the right. We hit OK, and notice we've got x greater than, just like we've got down here. And this is for the picture for x greater than 0, so the amount of the curve that is above the mean to the right of the mean greater than the mean is 50% as well. And again, we can put any number in here, sort of within reason, within the number of standard deviations we're given, say 2.5, and we see, oh, that's 2.5 is just a little bit of the curve, right? And we get a very small number. Maybe if we go with 1.5, okay, we can see at 1.5, that's also, it's only 6.6%, right? About almost 7%, but it's just a little bit of the curve. So we get that with this. And so let's do 3 questions, and we'll see how this works. Find the cumulative area to the left of, let me get my marker here. So the keywords here to the left that correspond to a z-score of 1.15. So that's 1.15 standard deviations from the mean. Notice it is positive, so it's going to be to the right of the mean. Will the area be more or less than 0.5? That's kind of get you thinking. It's going to be, if we think of it, here's our normal curve. Here's 0. Here's maybe 1.15. And we want it to the left, so hopefully we're anticipating we'll get it shaded this way, and yes, it should be more than a half. Again, we just come over here, switch back to that, and we want the less than tool, so we go to that one, click OK, we put in our 1.15, and we hit execute, and yes, it is definitely more than a half because it's here. There's 1.15, and we can see it because of the scale on the bottom, the x coordinates here, the z scores, the x scores, right? So we can answer this one. Yes, it is 0.8749 to 4 decimal places. You could also, if they ask for a percentage, it would be 87.49%. So notice it has to have that percent key. So these are equivalent. So it just depends on what they're asking for. Okay, so we've kind of saved that in place. The next example, find the area under the standard normal curve to the right. To the right of this number. To the right is going to be something 1.06. Okay, again, we always go here 0. There's about 1 point. To the right is going to be just like this little area over here. So again, we come to our tool. We go down to the one that's going to shade to the right, the greater than, and we put in our number 1.06. That's our z-score, our x value, and we see that it's going to be about 14.45%. And we see just this little shading here. We can click over here to get this saved here, and what we see is that the area, yes, it's not more than half because it's less, right? It's going to be 0.1446 if we round it up. Okay, so we're getting that from this one right here. Again, you can also do this as a percentage, 14.46%, right? You multiply by 100, which gives us this as a percentage or as a decimal, whichever we need. So let's go. I need to clear off the screen. Do that, and we'll go to our next slide. Now this is the last option, which is between. Find the area under the standard normal curve. So remember, this is space, the volume, well, not volume, area, right? 2 dimensions. So the area under the curve, that's what we're doing, but we want to go from z equal negative 1.5 to z equal 1.25. So again, we come to our tool. Remember, if you're catching on and this is getting boring for you, you can always fast forward these videos to get what you need to get. You could also play these at faster speed, so minus 1.5. I know I seem to talk a little slow, but it's helpful for people who are learning the first time. And so notice we've got it. We can see it here. The area between the curve, yeah, that's about negative 1.5 because it's less, you know, it's to the right of negative 2. I could see from the scale right here. And then this is going to 1.25. I can see what it's giving me. And my answer, yeah, it's about 82.75%. And so we can write our answer 0.8275. And we also, move that up a little bit now, have this stored for us. Okay, so that's a nice thing with if you have the embedded one on your computer. There's a little screen where you can actually print off these your screen and then save them in like a Word file or something. That's all I've done here is I've printed these off from the calculator and gone forward. So that was our first section, and what you're going to see is now that you know this one, let's see, you're ready to do that first section of homework. The second section is going to be very similar, just one more additional step. So let's go here and clean my screen off. So now with these, we are not dealing with the standard normal. We are dealing with some mean other than 0, and oftentimes some standard deviation other than 1. So we're giving these. The only thing that's really different, we're still going to be finding the probability area under the curve. X is less than a number. This is not a standard score. It's not a z-score. All we have to do now is we have to back up and we have to change our mean and our standard deviation, and then everything will work just like we were doing on the first one. So 81.5. There we are. And now look how beautiful this is. We have a normal curve, and we have it in the units down here, our mean at 81. Now this is 80. So it's not exactly, but you can see the mean is a little bit past that, so it's going to be okay. And all I have to do is I still got my 3 different tools. If I want less than, I stick with the first tool, which is shaded to the left, and I just put in my number here. I don't have to get a z-score. I just put in 76, enter, and I have the percent that is less than 76. So this situation might be a test score. A test has an average of 81 is the score, standard deviation of 5. So how many students would have scored below 76? About 15.8687. We'll round it up, right? 0.1587 or 15.87%. Okay, and what we see is all we had to do is change the first screen, and then we use the tool in a very similar fashion without having to change the 76. I'm going to show you a couple more examples. Go to the next one. Let me get out these answers. Basically, you see the underlining I could have left. We just have to change the mean and the standard deviation, and then we'll put this one in, and notice this tool is x is greater than, so that means we're going to the right. We use the last tool, right? Just come here. First have to change our mean to 50, and then change our standard deviation to 7. And now we are set and ready to go. We have our normal curve set up, and we want greater than 43. So we come down here, we want the greater than, and we put in our 43. This is the percentage that is greater than 43. It threw me off a little bit, but yeah, 43 is below the mean, right? Below the mean of 50, we see that. So it's going to be everything to the right. It's 84%, right? So our answer here is just going to be 0.8413. Or if they want a percentage, it's 84.13%. Okay. And we can store that right here. Okay. Let's do a little bit of review. This next question will ask us all three: less than, between, and more than. So again, all we have to do is read through here. We're looking for the mean. I guess I could reformat this, but we have a mean of 100. Our standard deviation is 15. So the first thing we do is we change our settings here. And then we can answer each of these relatively quickly. Less than is the first tool, right? And that's what it usually defaults to, the first tool here. And we just put in $67. And again, this is a question we can understand. It's a utility bill, the electric bill. Averaging $100 a month, standard deviation of 15. So how many people, what percent of the people would have a bill less than 67 if this was the data that we were given, right? Well, about 14% of the people. And we can see it's a very small percentage. It's over here. We see our numbers here, and it makes sense. 67 is about there. So that is, no, not 13%, 1.39%. So let me read my numbers here. 0.0139 to 4 decimal places. Move the decimal place back 2 by multiplying by 100. So that is just 1.39% if this mean and standard deviation are correct and it's normally distributed. Okay. To get the between, and again, we can click on a few of these. This is our setup. This is less than 67. To get between, all we have to do is come back and change the subtool to the one between. We click OK, and now we can put in our lower limit, which is $88. And notice we're dealing right with the units in this case, and 120. So what percent of the people would have a bill between $88 and $120? We click OK. Almost 70%, right? And we can see the graph right here. I'll click here. We store it. We can use it. We could add it to our notes if we want. And this is going to be 0.6969 or 69.69%. Okay. And the last one, we've done one similar to this, more than 130. Again, we just come over and choose the right subtool. We're doing greater than now, more than, and we put in our 130. So what percent of the people would have a bill greater than 130? Not that many, some would, but that's about 2.27%, right? 0.27%. 0 to 2, actually we'll round it up to 8. So 2.28% if it's to 4 decimal places. Okay, so that's how we can do those. And now let's show this last one. It's set there for us. Let's look at one more example, and then you'll be set to go all the way through the homework. This one needs a little bit of problem solving as we go through it. Let's go with blue this time. Then use the normal distribution to the right. Actually, it's below, but I copied and pasted this from something else. On the graph itself, they're giving us the mean and the standard deviation. So our first step is going to be to actually enter those, right? Whenever we have a problem, we have to enter in these numbers. And the nice thing with this tool is it handles the decimals just fine. We put these into formulas and such. Sometimes working with decimals can seem a little harder, but this one just handles it just nicely. We've got our layout here. The first question, what percent of the scores are less than 19? We don't, we see the mean of about 20 here, 20.2. So we will see that it should be just a little bit to the left, right? Percent less than 19. Use the default. It's less than. It's already set to go. We just put in our 19. And we get our percentage, about 41%. Okay, so go ahead and store that there. And we could enter our answer here, 0.4121. So the 0 gets rounded up, again, or 41.21%. Now this one's a little challenging, can be. Out of 1,500 randomly selected scores, how many? So notice they're not asking about percent. Before, the questions were what percent are such and such. This is how many, so that's a number. Would be expected to be greater than 21. So we go about it, the tool is going to give us the percent, right? Not the amount, and then we have to do an extra calculation. So we want the tool that will give us greater than, more than. That's the second tool. We put in the value of 21, and that's telling us 44.11%. We write that down. So that's a percentage, a decimal, but we want to know how many of these 1,500 people does that represent. Remember, with percentages, all we have to do is multiply. So if we take this percentage and we multiply it by the 1,500, we will get the number of people. And to do that, the nice thing with the Numworks calculator, it also has a standard calculator built in for calculating. We just hit on the home key and we go up to our calculations and we can just enter it here, times 0.4411. It's 661. Yeah, it should be 662, because if we ever have a portion here, we would round it up to the next highest level of people. So 662 is what we're going to answer here. And you'll see that this will take you through the next series of questions in the homework. You get some practice with this. And again, the distribution is always going to give you the percent. And if you need an amount, you're going to have to do a separate calculation afterwards. And then we're going to build on these to understand how we can use statistics in multiple ways. But certainly this is the first step with the normal curves, both the standard normal and just a normal that has not been standardized. Ones with a mean different from 0 and standard deviation different from 1. All right. Thank you so much.